In the previous class, we have completed searching. In that, we have completed binary search, then inserting an element into the array. At the end, we have completed deleting an element from the array. Examples with algorithm we have completed. I'll repeat that three are very important for exam point of view as well as the marks point of view. Right? They are covering theory plus practicals. Today, again, same thing. Today's topic also very important to gain the knowledge as well as marks. So today's topic is, we are starting with sorting. But if you know that, what do you mean by sorting? Sorting is nothing but arrangement of elements of the array in some order. That is, arrangement of elements either in ascending order or in descending order. It means elements are arranged in some order. That is nothing but sorting. To perform that operation, in the data structure, we are using different methods like bubble sort, shell sort, selection sort, quick sort, insertion sort, and so many. But for our syllabus, PU syllabus, we have insertion sort method is there, right? For that, today we'll start that insertion sort. In the insertion sort, the first element of the array is assumed to be in the correct position. It means the first element in the array we are assuming is as, that is in an order, sorted order, that is in the sorted form, remaining or in unsorted forms. The next element is considered as the key element and is compared with the elements before the key element and is inserted in its correct position. The first element we have considered as, that is in the correct position, then remaining elements, the next elements is considered as key, that will be compared with the first element, then according to the condition, they may exchange the positions or else they may be in the right position. This process goes on until all the elements will occupy their correct positions. This is about the concept of insertion sort. To understand this, we'll take one example, then we'll come back to the algorithm. See here. In this example, the given array in this, see here, this is a given array. The elements are 19, 12, 5 and 7. They are in random order. Total we have 4 elements in the array. Their positions are 0, 1, 2 and 3. Now, in the insertion sort, what we are assuming is the first element, this one 19, the first element in the array is assumed as, that is in the correct position. It means 19 is in correct position, we are assuming. Then the next element, that is 12, we are considering that next element as a key element, that will be compared with the first element. If the key element is smaller than the first element, then shifting of these two elements position takes place. Otherwise, keep it as it is. This process goes on. Now we'll check out the examples how it works. See here. 19 and 12 is there. 19 is the first element, 12 is the key element. If this 12 a of 1 is less than a of 0, a of 1 is a of 1 less than a of 0. It means 12 is 12 less than 19. Yes, condition is yes. A of 1 is less than a of 0. It means interchange takes place. Both the elements will interchange their positions that we have shown in second array here. See, 12 as 19 are interchanged their positions, then they occupied their correct position now. At this point, what we'll say is that 12 is in the correct position. It means first two elements are in an order. Now we have to start with the third element of the array that should be compared with the first two elements. See here, 5 now. First two are in sorted order, remaining two are unsorted order. Now this 5 we are comparing with 19. It means is A of 2, what I am assuming is A is an array, is A of 2 is less than A of 1. Yes. 5 is less than 19. It means these two will interchange the position. 5 comes this side, 19 comes this side. 5 has occupied position 1. Now it will not stop here until and unless it reaches its destination, correct position. Again, the comparison takes place. Is A of 1 less than A of 0? It means is 5 less than 12? Again, yes, condition is yes, 5 is less than 12. Again, interchange takes place. It means 5 has reached the 0th position. 12 has reached first position and 19 in position number 2. That is shown in this array. See, 5, 12, 19. It means after completion of this process, first three elements are in an order. Now, we'll continue the process. This 7, that is A of 3 compared with A of 2. Is A of 3 less than A of 2? It means is 7 less than 19? Yes, condition is true. It means interchange the positions. Swapping takes place. So 7 comes at position 2, 19 goes at position 3. It will not stop here, it continues until it reaches its destination position. Again, 7 is here, 19 is here, interchanges. So this 7, A of 2, again we are comparing, is A of 2 less than A of 1? That is 7 less than 12? Yes, again condition is true, 7 is less than 12. Again, interchange takes place, 7 comes at position 1 and 12 goes to position 2. Again, the process continues. 7 is at position 1 now. So, is A of 1 less than A of 0? That is 7 less than 5? No, no means that has occupied its correct position, right? That you have shown in this array. See here, 5 as it is, then 7, 12, 19. It means the elements of the array are in an order now. Sorting completed. The method we have used is insertion sort. Initially we taken 19, 12, 5, 7. This is the given array. After sorting we are getting 5, 7, 12 and 19. I hope you understood this concept. Now we'll move to the algorithm. This is easy now because we have learned how it works. Now see here. So here if you observe, the algorithm starts with, say, let A be an array with n unsorted elements. A is an array that has n elements. They are unsorted. They are not in any order, random. They are in random order. They are not in ascending order or descending order. They are in random order. That's why we are using one word, that is unsorted elements. The algorithm now. How the algorithm works, we'll say. Step number 1. For I equal to 1 to n minus 1. You consider here. Normally in the arrays, we are considering in the looping for I equal to 0 to n minus 1. But Now in this case, we are starting with 1. Why? Why are we starting with 1? Why not 0? This is the first concept we are getting it here. Step number 1 is concept oriented. If you know the concept of insertion sort, then only we are capable of writing this 1. Otherwise, we'll start with 0. That is wrong. For I equal to 1, it starts with 1 to n minus 1. Why 1 to n minus 1? Why not 0 to n minus 1? Because what the insertion sort states that the first element of the array is in correct position. It means other than first element, you have to compare remaining elements with the first element. First element is in correct position. Next element should be compared with that. That's why the first element we are skipping here. We are starting with the second element, that is 1. Based on that concept we are writing here, I value starts with 1 to n minus 1. Is it clear? Now, step number 2. J equal to I. J equal to I. And temporarily, we're taking that original value, we want to keep it as it is, I value. Now, J we are using for processing. That's why we are taking that variable here. The value of I is assigned to J. J value is 1. Right? Because I is 1. Now, the while statement. While, right? While A, that is J means 1. J is greater than or equal to 1. It means at least there should exist one element that we are doing it here. While 1 is greater than or equal to 1. Yes, it is equal to. Condition is satisfied. Now it moves to the body of the while. That is, if A of J less than A of J minus 1. What is J value? J value is 1. It means if A of 0 less than, A of 1 less than A of 0. A of 1 less than A of 0. It means we are comparing the sorted element first element with the next key element. That is, if this condition is true, A of J is A of 1 is less than A of 0. Right? See here, this example we are taking. A of 1 is less than A of 0. See these two. 12 less than 19. A of 1 less than A of 0. 12 less than 19. Yes, condition true means what to do? You have to interchange the position. 12 comes at 0th position, 19 goes at first position. That we are writing it here as, see, if A of 1 less than A of 1 minus 1, that is 0, then interchange takes place. That we are writing with the help of these 3 steps. Interchanging the 2 elements. Interchanging the position of the 2 elements. The first A of 1 should come to A of 0 and A of 0 element should go to A of 1. 12 should go to A of 0 and 19 should go to A of 1. That we are writing it as A of J is assigned to temp. To interchange the position, we need one temporary variable. I hope you still remember that the PUC first year's practical program, interchanging the 2 variables. First program you have learned these 3 steps, right? How to interchange the 2 values. That same concept we are continuing here. A of 1 is assigned to temp. Now A of 1 is empty because that value is assigned to temp. What is A of 1 in the example? It was 12. 12 is assigned to temp. Now 12, that A of 1 block is empty. There what we are doing? A of J value is 1. 1 minus 1 is 0. A of 0 is assigned to A of 1. It means 19 is shifted to A of 1 from 0th position to first position. Now temp contains that value 12. A of 1. That temp is assigned to A of 0. 12 and 19 are interchanged in account of our previous example. It means if this condition is true, interchange takes place with the help of these 3 steps. Then in the next time, the number of elements remaining is 1 less than the previous size. That we are writing it as, see here, that we are writing it as j equal to j minus 1. Previously j was 1. Now 1 minus 1 is 0. Right? 1 minus 1 is 0. Then when j becomes 0, what happens? If j is 0, again it goes back to while here, right? While 0 greater than or equal to 1, no. No means again it goes back to for loop, right? The value of I will be incremented by 1. At that time, I value becomes 2. 2 to n minus 1. It means, according to our example, third element. 3 to n minus 1, like that. Right? This process goes on. Once all the elements are in an order, then step number 4 will be executed. That is exit. Step number 4 is exit. That is, sorry, step number 3 is exit. I hope according to that particular example, based on that, we have understood the concept of insertion sort with the algorithmic steps. Now, after knowing the insertion sort, the first part of the array completes here. That is one-dimensional array. We have completed one-dimensional array, and their operations are completed here with an examples. Now we move on to the second type of array, that is two-dimensional array. Two-dimensional array. The two subscripted arrays are called as two-dimensional array. This is the definition already we have defined. Number of subscripts are 2 here. One for row, one for column. That's why two subscripted arrays are called as two-dimensional arrays. A two-dimensional array is a collection of elements, and each element is identified by a pair of subscripts or indices, right? Each and every element in the two-dimensional array will be identified with the help of a pair of subscripts. It means two-dimensional array contains two subscripts. First subscript represents row, second subscript represents columns. With the help of row and columns, the two subscripts, we can easily identify the element in the array. Now, after knowing what is two-dimensional array, we move on to the next heading. For exam point of view also, this heading is very important, that is memory representation of two-dimensional array. For yesterday questions, this is an important one. Representation of two-dimensional array in memory, or memory representation of two-dimensional array. Either of that will be the heading or question. Now, suppose A is the array of order m cross n, that is m rows and n columns, one array. To store m into n number of elements, we need m into n memory locations. To store the elements of the array, we need m cross n or m into n memory locations to store m into n elements. The elements should be in continuous memory locations. Already we know that arrays stores all the elements in a continuous memory location. That is the advantage of arrays. If you know the address of the first element, easily you come to know the particular element address, because all the elements of the array are stored in a continuous memory locations. So in two-dimensional array, the memory representation can be done in two methods. That is, method number 1 is called as row measure order, and method number 2 is called as column measure order. It means in the two-dimensional array we are following two methods to represent the elements of the two-dimensional array in memory: row measure order and column major order. And this, first we'll study about the row major order. Let A be the array of order m cross n, m rows and n columns. In row major order, all the first row elements are stored in a sequential memory locations, and then all the second row elements are stored, and so on. This is very important. Related to the heading, row major order means all the first row elements are stored in sequential memory locations, and then all the second row elements, and then all the third row elements. This process goes on. That's why it is called as row major order. It means elements, row wise elements are stored. First row elements first, second row element next, like that. Base of A is address of the first element. How do we know that? Base of A means the address of the first element. We are calling it as base. Here A is an array. The first element address is nothing but base. The memory address of any element A of ij can be obtained by the formula. Once all the elements in a row major order are stored in a memory, means easily you can find the particular element's address if you know the base address of that array. With the help of a formula, that is LOC of A of ij equal to base of A plus W of n into I minus LB, then plus of J minus LB. This is the formula. Using this formula, easily you can calculate or you can identify the particular element position, where in this formula W is nothing but the number of words per memory location. Think you understood this. In the row major order, the array elements, the first row elements of the array are stored continuously. Then all the second row elements are stored continuously, and then all the third row elements are stored continuously. Like that, all the rows elements will be stored continuously in the memory. That's why the method name is row major order. And the base is nothing but the address of the first element. If you know the base of that base of that particular element, then easily you can obtain the address of any element in the array with the help of that formula, that is LOC of A of ij equal to base of A plus W of n into I minus LB plus of J minus LB. Now we'll consider one example. See here, in this example, the given array is this one: 2, minus 2 and 3, 2, minus 2, 3, then 1, 0, minus 3, 2, 2, 5. It means this is the order of 3 cross 3, 3 rows, 3 columns, 3 cross 3 array it is. Now, in the row major order, the first row elements, first row, this is called row, this is called column. In the row major order, the elements are stored row wise. That's why the title is row major order. The first row, 2, minus 2, 3. Second row, 1, 0, minus 3. Third row, 2, 2, 5. These are the row wise elements. In the row major order, elements will be stored row wise. That is why you can see here in the first row, that is A of 0th row, that is 2, minus 2, 3 are there. That they are stored continuously in memory locations first. Assumed address is 2001. A of 0, 0, that is A of 0, 0, A of 0, 1, A of 0, 2. First row elements, that's A of 0, 0, A of 0, 1, A of 0, 2. First row elements are stored continuously in memory locations 2, -2, and 3. Like that, in the row major order, after completion of first row, all the second row elements are stored continuously. That is A of 1, 0, A of 1, 1, A of 1, 2. That is 1, 0, -3. See here, 1, 0, -3 are stored in a continuous memory location. After completion of the second row, now the elements of third row, that is A of 2, 0, A of 2, 1, A of 2, 2. The third row elements are stored in a memory in a continuous memory location that is shown in here, that is 2, 2, 5. The continuous memory locations are used, that is it has started from 2001 memory address that is considered as the base of this particular A. A is an array, right? Its base address is 2001. 2001, 2, 3, 4, 5, 6, 7, 8, and 9. All the 9 elements are stored in a continuous memory location, but in a row major order, all the row elements are stored. First row element stored first, second row element stored next, and third row element stored next, right? So this is the method the row major order follows. Now, after doing this, we move on to the next method, that is column major order. In the column major order, as you have seen in the case of row major order, the row-wise elements are stored continuously. In the same way, in the column major order, the first column elements will be stored continuously in a memory location first, then the second column elements are stored in a continuous memory locations, and third column elements are stored in a continuous memory location. It means column-wise elements are stored in a continuous memory location. That's why it is called as column major order. See here, let A be the array of order m cross n, m rows, n columns. In a column major order, all the first column elements are stored in a sequential memory locations, and then all the second column elements are stored, and so on. It means the elements are stored column wise. The given array, the first column elements are stored in a continuous memory location. Next, the second column elements are stored. Next, third column elements are stored. Like that, it goes on. Then the first element address is called as base address. If A is the array, means base of A is the first element address. If we know the base of A, then easily we can obtain the address of any element of the array by using a formula called as LOC of A of ij equal to base of A plus W of I minus LB plus M of J minus LB, where W is nothing but words per memory locations. If you observe this theoretically, one and the same, only the slight change in the explanation, that is instead of row, we are now following the columns. Now we'll consider an example for 3 cross 3 matrix, that is 3 rows and 3 columns matrix. Then using that, how it stores, that you can check it here. See, this is the example. In this example, if you assume say the elements are same array we are considering here, that is A of 0, 0 is 2, A of 0, 1 is -2, A of 0, 2 is 3. The same array you are taking it for column major order also, but here in the memory, instead of row wise, in the column major order, the first column elements are stored first. If you take 2001 as the memory location of the first element, then 2 will be stored there. In 2002, 1 will be stored, and 2002 memory address, this 2 will be stored. It means column wise elements will be stored in a continuous memory location. Then 2001 is over, 2 is over, 3 is over, first column is over. Now after completion of first column, the second column elements will be stored in a continuous memory location, that is from 2004. At 2004 minus 2 will be stored. At 2005 memory location 0 will be stored. At 2005 this 2 will be stored. Then after completion of second column elements, again in the continuous memory location, the third column elements will be stored, that is 3 minus 3 and 5. Again from 2001 to 2009, all the 9 elements will be stored in a continuous memory locations. But in this case, the elements will be stored based on columns. First column elements first, then next column elements. Like this, all the column elements will be stored in a continuous memory locations, and the first element address we are calling it as the base address of A. So after knowing the row major order and column major order memory representation of two-dimensional array, now we'll take one example how to identify the address of a particular element with the help of both the methods, that is with the help of both the formulas, right? See now. In this, what we are assuming is, example, consider the array A, name of the array is A, of order 25 into 4 with a base value of 2000. 25 into 4, 25 rows, 4 columns. 25 rows, 4 columns. The base value is 2000 and 1 word per memory locations. It means W is 1. Find the address of A of 12, 3. 12th row, third column element. That address we want. In a row major order and column major order, you have to find out the location of the particular element, that is A of 12, 3. 12th row, third column address. What we are doing is 25 cross 4, 25 rows, 4 columns. Then base address is 2000. Our task is to find the address of A of 12, 3 element by using both the methods, row major order as well as column major order. Now check out the given. Given is base of A is 2000. It is given here. Base of A is first element address is 2000. Then what is M? M cross N, that is M is 25. What is N? N is 4. What is lower bound? Lower bound is 0. What is W? W is 1. That is also given here, right? 1 word per memory location. W is 1. Then I is 12 here, row. This is the row. Then what is J? J is 3. 12 of 3. 12 comma 3. 12th row, third element address we want to calculate by using both the methods. First, we'll start with the row major order. The row major order formula is to find this particular element address, LOC of A of ij equal to base of A plus W of N of I minus LB plus of J minus LB. By using this formula, you have to substitute the given values and you'll get the address of A of 12, 3 in row major order. That is LOC of I is 12, J is 3. So LOC of A of 12, 3. That is equal to base of A is 2000. A is 2000 plus W is 1. Then N is 4 of I is 12 minus LB is lower bound is 0 plus of J is 3 minus LB is 0. So I substituted the given values in the formula. Now you have to compute. So 2000 plus, see here, 12 minus 0 is 12, right, into 4. 4 into 1 is 4. Then inside the bracket 12 is there, 12 plus 3 minus 0 is 3, this thing. Then 2000 as it is plus multiply these two, 12 4 ja 48 plus 3, keep it as it is. Now sum all these, 2000 plus 48 plus 3, that is nothing but 2051. It means in a row major order, the A of 12 3 element will be stored at a memory location 2051. At a 2051, we'll get A of 12 3 element in a row major order. Like this, we can calculate. And a second method is, what will be the address in the column major order? So write the formula, that is to find the address of particular element in a column major order. LOC of A of ij equal to base of A plus W of I minus LB plus M of J minus LB. So substitute the given values in this formula, that is I is 12, J is 3, LOC of A of 12 3, then base is 2000 plus W is 1 of I is 12 minus LB is 0, right? Then plus of M is 25, so 25 of J is 3 minus LB is 0. Now compute this, 2000 as it is, right? 12 into 12 minus 0 is 12, right? Then 3 minus 0 is 3, 3 into 25 is 75, that is 1 of 12 plus 75. Now 2000 as it is, 1 into 12, 12 plus 1 into 75, 75. So 12 plus 75 is nothing but 87. So 2000 plus 87 is nothing but 2087. It means in the column major order, the A of 12 3 element stored at a memory location 2087. This is the way you have to calculate the address of particular element by using these two formulas. If you found any difficulty in the today's class, just post your questions to get the answers. In the next class, again, we'll continue with the applications of arrays and further next topics. Thank you.